Okay, welcome back, and today we're going to start section 6 of chapter 3. And today we're going to talk about negating conditional statements and DeMorgan's Laws. And then we've actually seen DeMorgan's Laws being applied, but we haven't called it DeMorgan's Laws. Well, today we're going to see that in action. So we're going to write the negation of a conditional statement, and then number 2, the objective is going to be being able to use DeMorgan's Laws to negate compound statements. Okay, now these are typos, so this is not what we're looking at. So the negation of this is going to be P. This is going to be P and Q. Okay, so if we write this, let me rewrite this because I don't like this is a typo. I can't change it. So if we have P and Q, so the negation of P and Q is going to be not P or not Q. Okay, and so we can express this symbolically as the negation, so forget about this is typo, so the negation of the quantity of P and Q, get rid of that, okay, so the negation of the quantity P and Q is equivalent to not P or not Q. Okay, and that's the equivalent statement. So that's the negation. So if we write the negation of this one, it says if too much work is given, a class should not be taken. So we could say that this here is P, and this is Q, right? So if P, then Q, right? So write the negation of this statement. So how do we do that? Well, P, again, too much work is given. Q, a class should be taken. And so symbolically, that means this. So what we want to do is we want to take the opposite truth values of this. So we know that the only time this is false is when this is true and this is false. Okay? That means when this is true and this is false. Okay? That's the only time this will be false. Okay? Well, the negation of this thing is going to be when P is true and this is false, which means, we're going to take the opposite value of this thing, okay, which gives us Q. So the negation of this implication is P and Q in this case. So what we're going to do is then do that. So P and Q. In this case, P is too much work is given, and Q, a class should be taken. So the negation of P implies not Q is P and Q. So the negation of this gives us this, and so what we're saying is that too much homework is given and the class should be taken. That's the negation. Now the conditional statement, so if we start with the conditional statement, P implies Q, hold on, right? Then this is going to be equivalent to what? This is equivalent to the contrapositive, right? So this is not Q implies not P. Okay? Converse and inverse. Okay? Converse and inverse. So P implies Q is not equivalent to Q implies P. The converse. Okay? So these are not equivalent, right? So the conditional is not equivalent to this, right? We've seen that before with truth tables. And the conditional P implies Q is not equivalent to the inverse, which is just not P implies not Q. Okay? Again, just disregard this. Okay? Now the negation of the implication is going to be what? P and not Q. So let's get rid of this. So it's going to be P and not Q. That's the equivalent statement, because think about it. The only time this is going to be false if this is true and this is false. So this is true and this is false means that the whole thing is going to be false for an and statement, because in order for an and statement to be true, both of these have to be true. Well, let's look at this. If this is true and this is false, then this is false, which is the same thing as this. This is true and this is false, right? So if this side is true and this side is false, well, here, if we have true, true, that means we have this, right? So P and not Q. Well, what if we have, if this is true and this is true, well, what do we get? True and false. Okay, so the negation of this thing, right, gives us the opposite truth values. So if this is false, this becomes true. When this is true, this becomes false. And so again, we could use the truth tables to show this. But think about it. This is going to be false when this is true and this is false. Well, if this is true and this is false, that means this is true and this is true, which gives us a true statement. When is this true? Well, if this is true and this is true, in this case, this would be true and this would be false, which would be false. When this is false, well, this whole thing is going to be false. We know that if this is false, this whole thing is automatically true. Well, if this is false, we know this whole thing is going to be false. So they do have the same truth values. Or excuse me, they do have opposite truth values. So these are negations of each other. Now, DeMorgan's Laws. Okay, let's look at this here. Okay, because this is typos. These are not correct. Okay, so DeMorgan's Laws, the first law says if I negate P and Q, Oops. Okay, and so this, if we distribute, DeMorgan's law says that if we want to distribute the negation across the and, then we have to flip the sign and then negate both sides. So this is going to be equivalent to not P or not Q. Sorry about my writing. It's a little sloppy, but so DeMorgan's law says we're going to distribute. So this is sort of like the distributive law for logic. So we can negate both sides, right? So we can distribute the negation by flipping the sign, the symbol, from and to or, and then negating both sides. So we get not P or not Q. So these are equivalent. And then similarly, we can do the negation of the quantity P or Q, and this is going to be, again, distribute the negation and flip the sign. So it's going to be not P and not Q. So this is DeMorgan's laws. Okay, so these are equivalent. So the negation, so in other words, if we want the negation of P and Q, we can write it this way, or we can write it as not P or not Q. If we want the negation of P or Q, then it's going to be not P and not Q. Okay, so that's where DeMorgan's laws come in. So now the proof that the first law is shown in the truth table. Okay, so if we look at this negation and we compare it with this, and again we can show equivalence by showing that they have the same truth values going down the table. And again, so if you construct your truth table, you can show that these two are indeed equivalent. And so what I would do is also do that for the second law, and show that they are indeed equivalent statements. Okay, so now DeMorgan's laws and negations. Again, we have the general law. Again, this is P, the negation of P and Q is equivalent to not P or not Q. Okay, so again, this here. So what is saying? The negation of P and Q is equivalent to not P or not Q. So then to negate a conjunction, you negate each component statement and change the and to or. And just like with the second one, we negate an or statement, negate a disjunction, we negate both sides, we negate each component statement and change the or to an and. Okay, so again, these are just typos here. Okay, so again, this is going to be the negation of P or Q and to get the equivalent statement using DeMorgan's laws, we'd negate both sides and flip the sign from and to or in this case, or to and. And we're done. Okay, so now, write the negation of each of the following statements. So the first one says, all students do laundry on weekends, and I do not. Okay, now, so this is an and statement, so it's a conjunction. So to write the negation, we're going to make this to an or, right? So change this to an or, and we're going to negate both of these sides. So this means, well, we're saying all. So this is a quantitative statement, right? So what we're going to do, it has a quantifier. Okay, so we're going to take this all and change it to some. So all students do laundry on weekends. The negation of that means some students do not do laundry on weekends. Okay, so and then the negation of I do not means I do. So this would be the negation of this conjunction. So what about this one? Here it says some college professors are entertaining lectures, or I'm bored. Okay, so we take this disjunction, right? So it's a disjunction with or. Okay, and so if we want to negate an or statement, a disjunction, then we negate both sides and change this to an and. So what we do is we change this, so now this is a quantifier, right? An existential quantifier. So that means if we say some college professors are entertaining lecturers, and we want to negate that, that means that we would say no college professors are entertaining lecturers. So we negate that side. Change this or to an and then we change I'm bored to I'm not bored. And so this would be the negation. And so that is the end of this section. So again, make sure you're practicing these. Please make sure you watch these videos before lecture. Again, this is the power of the flipped classroom, is that you get to watch the videos, and when we come to class, that's where we're going to jump into practice, and we're going to do group work. And so make sure you're taking your notes on these videos. Write down your questions if you have any. Bring those with you, and we'll tackle those in class. If you want to reach out to me and email me, you can do that as well, and I will answer any questions you have, especially if it's homework and stuff. But again, a lot of our time in class will be working on problems and practicing and working on homework and things like that. It just depends on the day and the time. So anyway, until then, have a great day.